Hello, dear students. As you know, we stopped last lecture on how to find a particular solution for a second order differential equation. Today I will speak about undetermined coefficient method, which is very easy and simple to use. However, it has some limitations. I will show you some examples and I will give you an idea about what particular solution mean. Okay, if you remember, my second order differential equation is in this form. Is equal to some function q of t. A, B, and C are constants, and you have an action. So as you remember, we have an engineering system. You have an action. This action is q of t. Okay, it is not homogeneous, and you want the response y. Y of t. So the solution of this equation actually is two parts. General solution is equal to y homogeneous plus y particular. Y particular is most important and it will control your design. Okay, so what does it mean y particular? If you remember, I gave you last lecture that there is for example a floor or a machine sitting on the floor, okay, and you want to find the vertical vibration y. This machine is rotating with some frequency omega, and because of mass eccentricity this will give vertical and vertical vibration on the floor, and you want to obtain how many millimeters or what is this function it will be like. So this is the particular solution. The particular solution depends on the characteristics of the action. Okay, action force. If you apply a vibration on this slab by 5 Hertz, for example, this slab or this floor should move by 5 Hertz. Okay, so the same characteristics. It has no way it should move by 5 Hertz. Also, if you remember the washing machine, the washing machine is vibrating with the, if you have the engine frequency is for example 1000 round per minute, the washing machine should vibrate with the same frequency. Okay, so if my, it has no way, okay, it should have the same characteristic of the applied force. So for example, if my action here is equal to, for example, 7 sine 20 t. Okay, so the angular frequency omega is 20. Okay, so you should assume that your y particular is equal to sine 20. Okay, it should have the same frequency of the action. However, the amplitude of your displacement or amplitude is unknown. You should calculate this amplitude, okay, which is how many millimeters it will vibrate. Okay, so this amplitude is unknown. We call undetermined coefficients method. Undetermined coefficient method. So usually your particular solutions depends on the action function. Suppose that your action function is not a sinusoidal. Your action function is exponential. For example, you have here 5e to the 3t. Okay, so your particular solution, assumption, okay, should have the same characteristic of the action, but the amplitude you should find. Okay, amplitude should find. This amplitude, of course, is not that one, because this is, for example, a force, and this is a displacement, so they are different physical actions. Okay, so it should be not the same. Okay, this is in Newton, this is in a millimeter. Okay, so this is what we mean by particular solutions. So the particular solutions have the same characteristics of your applied function. So let us see, this is first one. The second one in this method, this assumption that you assume this function here, which is the same function, acting function, okay, or here same acting function, should be different than the homogeneous solution. You have here a homogeneous solution, okay? So this function should not exist in the homogeneous solution. It should be different, okay? Because if it is the same, so it is not independent solution, okay? So this function should be different, so we will see some examples about that. So suppose I have the equation, example, I have the equation y double prime plus 4y equal to 4e to the 2t. I want to solve this. Okay. So it has two parts, y homogeneous plus y particular. Today I will speak about this part, but you should find the y homogeneous first. I will tell you why. So let us find the y homogeneous. Y homogeneous is to find y homogeneous, I will write the characteristic equation lambda square, okay, plus 4 is equal to 0. If you take this to the other side, so from here lambda 1 and 2 is equal to plus or minus 2i. Okay, so this is as before. I will not spend time here because you know how to solve homogeneous equations. This is a kind of sine and cosine function. So the y homogeneous is c1 cosine 2t plus c2 sine 2t. Okay. Now keep it in here, please. Now y particular, you should assume in this undetermined coefficient method, your y particular is equal to the same characteristic of this function, which is e to the 2t. However, the amplitude you don't know. The amplitude of this, or a, and the coefficient that is not known. Okay? So, you should stop here and look to the homogeneous solution. Is this function e to the 2t exist in the homogeneous solution? In this case, it does not exist. You have here sine and cosine, and it does not exist. Okay? So your assumption is okay. You can continue. Okay? So this particular solution should satisfy this equation. So you should obtain the first derivative, second derivative. You will put here the second derivative, you will put here the function, and then you will find this undetermined coefficient a. Okay? So let us do that. So if I find now y prime, what is that? This 2a e to the 2t, y double prime is equal to 4a e to the 2t. Just multiply it by that. So I will plug my y double prime here, by y here, and I will equate the coefficients. So I have here, this is my equation. I will have here 4 e to the 2t. Okay, this is the right hand side. Left hand side, I will have this y double prime, which is 4 e to the 2t, and I will have 4 times y. My y is this, a times that, so it is 4 times that, so it is plus 4 a to the e to t. 4 plus 4 will gives you 8 a e to the 3t is equal to 4 ut. So this will cancel with that. From here my a is equal to 4 divided by a. 8 is half. Okay, so now my undetermined coefficient is half. Okay, so my particular solution, I will put this half here. Okay, so I will just put this half. So now I know this, I find the solution. Okay, so I find this is the solution. So this is y particular, and I find x. So the general solution is sine plus c2 sine 2t plus half e to the 2t. So this part from here to here is y homogeneous. This part from here to here is y particular. Okay, so you see we find y particular. Y particular doesn't depend on the initial condition. Okay, it depends on the C1 and C2 can be found from the initial condition. Okay, I hope that this example is clear. Let us take another example. Let us take another example from one of the books. It was y double prime plus 3y prime plus 2y is equal to 4 e to the minus 2t. Okay, this is what I have here. So again, I'm looking for two things, homogeneous and y particular. So if you solve this for y homogeneous, I will write the characteristic equation. Lambda squared plus 3 lambda plus 2 is equal to 0. This is 2, 3, and this is. If you solve this, you will obtain two roots. This is 2 and this is 1, plus lambda lambda is equal to 0. From here, lambda 1 is equal to minus 1, lambda 2 is equal to minus 2. Okay, so I have two real roots and they are not equal. So from here, my homogeneous solution is equal to excluding this one, my homogeneous solution is equal to e to the minus t plus e to the minus 2t. These are the roots, minus 1 and minus 2. C1, C2. Now I will use undetermined coefficients to solve for that particular solution. Okay, so y particular, I will assume y particular is have the same characteristic of the applied function as before, e to the minus 2t, okay, times a. This is the unknown amplitude or unknown coefficient. If you look here, what you will find? You will find that this function that you assume exists in the homogeneous solution. So this is not independent solution. It should be different. So from theory, I will explain this later to you. The same as we say before in the homogeneous case. When this is equal to the same that function, you should make it different. So you should multiply this by t. Okay, to be different. So now this function is different, is not exist in the homogeneous solution. Okay, so I will tell you later from where this t comes. It comes from theory. Okay, if you know one of the solution, you can find the other solution. There is such a theory. But for now, you just will be an engineer, so you just understand that this should be different. So multiply it by t. Okay, that's it. So now I want to find what is a. Okay, what is the value of a? So I will just cut the derivative for this. Okay, and I will plug in the equation. So y prime is a is a product between two functions. Okay, so dot product between two functions. So the first function you will say a multiplied by the derivative of the second function. This is minus 2. Minus 2 will come here. A t e to the minus t plus the second function, which is this multiplied by the derivative of the t is equal to 1. Derivative of this is equal to 1. You've got again the second derivative for that. So again here you've got the product between these two. So you see this times that gives you 4 and plus a times t e to the minus 2t plus the second function, which is gives you here in minus 2a e to the minus 2t times the derivative of the t is equal to 1. The derivative of this is minus 2a e to the minus t. Okay. So this minus 2 and minus 2, this will gives you minus 4. Okay. The minus t. Okay. So I will plug this in the equation. I will plug, or you just do the following. I will plug this in the equation, and I will equate the coefficient in the right side and so on. This is the right hand side. I have here 4 e to the minus 2t this side, and in this side, what is the coefficients? What is the function e to the minus 2? In this case, I have e to the minus 2. So in this side, I have here. Do you have e to the minus 2 here? No, this is t time, so I will not take this. Do you have e to the minus 2? Yes. I have this, and I should multiply this by 3 because I have 3 here. So this is multiplied by 3, this multiplied by 1, this multiplied by 2. Okay, multiplied by 2. So it will be a 3 times that, so I have 3a to the minus t. Okay, and I have the last one, 2 multiplied by 4 minus 4, so it will be, I think we make a mistake. Okay, so it will be this one, yes, and minus 4 times 2, it will gives you minus, let us check again. So I will plug in the equation, sorry, this is no need for that, okay, because I don't have this exist. So I have this one is 3 times that, I put this here, and I have this is multiplied by 1, sorry, this is multiplied by 1, this is multiplied by 2, this is multiplied by 1, sorry for that. So I have here exactly what I have, minus 4 a e to the minus 2t. Okay, so from here I have minus 4 and plus the 3, so you got minus 1 a to the e minus 2t, and this is I have here 4 e to the minus 2t. Minus 2t will cancel minus 2t, so from here your a is equal to minus 4. Okay, so I find the value of a here is equal to the minus 4. What I do, I just got the derivative of this 2 times, and I plug in the equation. Then I got equating the coefficients of the function e to the minus 2x in the right hand side with the coefficients of the function e to the minus 2x in the left side, and I find that the value of a is equal to minus 4. So the value of a, I find it equal to minus 4. This value of a is equal to minus 4. I find this undetermined coefficient. So the final answer is y general is equal to c1 e to the minus 2t plus c2 minus t minus 4 t e to the minus 2t. Okay, so this is my y particular, this is my y homogeneous. Okay. Last thing, I will have 2 minutes more. So as you see, this should be different than the homogeneous, so I multiply by 3. Okay, so the last, I will not give more example, but just I will give you an idea about. Next video I will give more examples, but for now I just want to say something. So we say this is the system, this is the acting function qt, and this is the response y. Okay, so this is your engineering system. Okay, so an undetermined coefficient method works only with the following functions. Work with if your function is exponential, it works. So if your q of t is e to the alpha t, okay, any number here, okay, so you will assume that your particular solution is equal to a to the e alpha t. Okay, so it has the same, but we have to find a. Also, it works with what we call polynomial. Suppose that is your qt is 5t cube plus t, for example. Okay. Suppose that this is your q of t. So your y particular, you should assume a polynomial. My polynomial starts with t cube. Okay, so you'll say at cube plus bt squared plus ct plus d. Okay, so you will assume all the coefficients. You don't know a, you don't know b, you don't know c, you don't know d. So you should find all these coefficients. Okay, so this is your assumption for that. Even you don't have here t squared, you should also assume this value. So it works with a polynomial. If you have a sinusoidal function, for example, sine, suppose that your qt is 20 sine 18, for example. This is qt, for example. Okay, that sinusoid. You should assume a function that has the same frequency of 18. Okay, so y particular is a sine 18 t plus b cosine 18 t. So you should have the same angular frequency, and you don't know the coefficients a and b. Okay. And lastly, you may have a combination. So it works with exponential, polynomials, and sinusoids. This can be sine and cosine. Okay. So it can be also a combination. For example, x squared multiplied by 3t. Suppose that is your action. Okay, or t squared in this case. Sorry, t squared multiplied by that. So you have a polynomial multiplied by exponential. So in this case, this is your qt. So your yp is equal to, this is a polynomial, at squared plus bt plus c multiplied by the function that. Okay, so you should have this a, e, and c coefficient. This is your assumption, and this assumption should not be included in the homogeneous solution. If this assumption is included in the homogeneous solution, you should multiply this assumption by t. Okay, so hopefully this is useful for you. See you in the next video, and I will give you later more examples about this. Thank you for watching, and follow up my channel.